My name is Dori Exterman. I'm from Xoreax. I want to show you a technology today which we call process-level virtualization. I'll start by saying that NVIDIA uses our product. Our product is fully commercial. It's very mature. It's already 12 years in the market. And to continue the last presentation, we have NVIDIA running our product in a grid environment with more on Windows with more than 1,000 to 4,000 nodes, which are on Windows, so it can work. They achieve a lot of acceleration with our product. But what I wanted to say is to talk about today is the underlying technology behind XGE, which this technology is based on process-level virtualization. You are familiar with virtualization, and usually virtualization is for an entire machine. And what we do is we have the technology to virtualize a single process or several processes. And in this way, we are able to utilize idle CPU cycles of existing hardware instead of forcing our customers to buy expensive dedicated hardware. So customer which wants today to achieve acceleration for their application, and I'm speaking of computational processes, they have usually two ways they can go out and have this goal. One of them is usually grid. I think you heard both of them today. There are many surveys that show that most large companies has already enough processing power in their existing hardware in order to achieve all the processing needs they require from their application. If you're talking about financial, CAD, CAM, and other intensive processes, calculation processes. So usually you don't need, if you are able to utilize existing hardware, large companies will not need to buy extensive hardware in order to accelerate the process. They only need to have the ability to take advantage of the existing hardware they have, and this is the trick that process-level virtualization is able to achieve. Common grid solution is one way to achieve such a goal, but it takes usually a very, very intensive development effort. Even in the POC level, usually you need to put a very large amount of effort. You need to restructure your existing application. You need to change your source code. You need to follow up the changes in the API of the grid company. You have a lot of maintenance. You need to virtualize part of the software you want to accelerate on remote machines. The other way that companies are going to is virtualization, clusters, but this solution usually misses the target, which is utilizing the existing hardware, and then you need to buy more and more servers in order to gain acceleration for your application. And when we're speaking about application which goes to the customers, you force your customers, if you have an application that is computation intensive, you force your customers to buy dedicated hardware, and then you make your application and your solution more expensive than it should be. Process-level virtualization uses a combination, the best of the two worlds, while providing many additional features and several benefits, which I'll show you later on. So, XGE, as I said, is very mature. It's 12 years already in the market. We accelerate window-based application by a factor of 30 and even more. It depends on the application itself. What we do essentially is we transfer a private LAN into a private grid, a private cloud for use of computational intensive processes. In this private cloud that we create, every node in that cloud is actually a virtual supercomputer which can scale up according to the number of hardware you put into the grid. So this technology is used by more than 2,000 companies. It has more than 100,000 users around the world. As you can see, we have a lot of well-known companies using our solution in many fields. Some of them are code builds. In development fields, it's code builds and stress testing, QA. We have CAD, CAM, simulation, rendering, a lot of computational intensive processes. So how does it work? I don't want to go into details because it will take most of the time I have. Actually, it requires a lot of internal knowledge and extensive knowledge of the Windows API internal in order to achieve this process level virtualization. What I want to show you is what results of it and what benefits can be achieved from utilizing this kind of technology. So essentially what we do is, let's say that we have a command, a task, that instead of running it on an initiating machine, we want to be able to run it on a remote machine. If we take this task and multiply it by 1,000, by 10,000, this is more or less the environment we are giving an answer to. So what we do, if we take this initiating node and we'll run this command, XGE, in fact, will take this task, this XG console, which is our task, and create some kind of virtualized environment on top of it. And then when this task will be executed, instead of running it in the initiating machine, this task will be executed on a remote node. Once we'll execute this task on the remote node, XGE constructs a virtualized environment surrounding this task. So each time this task will require any information from the initiating machine, if it's a registry or DLL or executing a process, directory information, or anything else which is actually located on the initiating machine or not the helper, this virtualization environment will just go to the virtualization that resides on the initiating machine and get all the information required from the initiating machine instead of getting it from the helper node. So what we have here is a process level virtualization. As you can see, the task itself, the process itself, will not have any interaction with the remote machine on which it's running on. Actually, it will be passed to the initiating machine and then to the operating system on the initiating machine.
You don't have to do any special installations like.
Yeah. Okay. This is the second point. The only thing you need to do in order to achieve this virtualization is only to install our agent. You don't need to do any kind of installation. You don't need to copy the DLLs you want to use. I think that the most important thing of process level virtualization is the on-demand virtualization. We are not virtualizing anything in advance. We just execute the process. Our virtualized environment surrounds this process. And every time this process requires something from the initiating machine, it virtualizes this information on demand. The only thing which is not virtualized is things which are required from the operating system itself. If these are not files or something like this, but for example, if we need something which relates to DirectX or some operating system specific DLLs, then we enable the Windows API calls to go to the remote operating system. And in that way, we are able to have an initiating node of Windows 7 and helpers which are XP, Vista, or any other Windows operating system. So in order to summarize it, so what we do essentially is we install our agents on each machine. Once these agents are installed, our software creates a private grid, a private cloud environment of all of these machines. And each machine now becomes a supercomputer machine which can utilize all the idle CPU cycles of all the other machines which exist in the network.
You just broke per machine license mechanism.
What?
You just broke a per machine license.
Something like that.
If you open in the helper side a large file, what is happening?
Okay, so first, this technology requires, as I said, intimate knowledge of the Windows API. You need to encapsulate all the possible calls a process is making to the Windows API operating system. So what we need to do essentially is to understand all the API calls that a process can make to the operating system in order to know which one is a file related, is an IO related, which we want to virtualize from the initiating machine, and which one is a legitimate operating system on which we want the node machine to use its tasks. So a large file, if you open a large file, this file will be transferred from the initiating machine to the helper machine, and then it will be cached on the helper machine. So when the second time the helper machine will require this file, it will be there unless it's changed in the meantime.
So it copied the file from the initiating node to the helper?
Yeah, yeah.
If it's a network,
If it's a network, it could go directly to the node. Yeah, yeah.
So it's good for compilation?
Actually, one of the solutions that are based upon XGE is Incredibuild. Maybe some of you have heard about this product. Yeah, okay. So Incredibuild is a very mature product, which is the de facto tool for long compilations, and it's extensively used by, I think, most of the big software providers in the world, including Intel, NVIDIA, SAP, Microsoft, and more. Incredibuild accelerates Visual Studio build time by using this technology. So instead of having a build of let's say 20 hours, you can achieve the same build in half an hour time. And this is done using this technology. But this technology is not only for build, it can be used for any intensive CPU, intensive computational processes. 1 second, I will just go a bit forward and then you can ask me some questions. Okay, so the second thing I wanted to see, this is a very simple scenario on which you can take a lot of command lines and just, instead of running them on the initiating machine, just force your application to run it remotely. So we can actually take an application existing today and inside your application saying that I want this and these processes to run remotely. And it will coexist with the application. You don't need to change any of your source code today. This is also used with IT when they have a lot of scripts overnight and stuff like this. So they can just change the script, and instead of just running task.exe, they run XG console, and this is it. It's very simple to use. I wanted to show you another. We have 3 kind of interfaces, but the thing that really differentiate XG from and process level virtualization as a whole from other grid providers is the way we interface with the application. Instead of interacting with a specific API, usually provided by a grid vendor, the interfaces XG is providing are coming from outside the application. So they are external to the application. You don't need to change the source code. So if I take this example, let's say, for example, that I have, and this is a real life scenario, okay? Let's say that I have an application which runs a lot of simulation processes. Okay, so the main application with the GUI and all of this is called simulation application. And let's say that the processes which are executed are simulation process. And this simulation application executes tens of thousands of these simulation processes, each one with different parameters in order to calculate, for example, n variable problem. Okay, so the only thing required to do for this application is to write a short XML file describing the processes which are part of the entire solution. And in this example, what you see is that we have the simulation application, and we say that I want to intercept this simulation application because it's running on the initiating machine. And I want the simulation process to run remotely. So what we do, the only thing is left to be done after writing this XML is launching the application using XGE with a very simple command, okay? And then what's happening is that XGE is running the simulation application on the initiating machine, and it constructs a virtualized environment surrounding it. And each time this simulation application will create a process by calling Windows API create process, XGE will listen. And if you will see that the process name is simulation process, instead of running this process on the local machine, it will look for one of the machines that currently exists in the private cloud we created, and will execute the process there instead of executing it on the local machine. Nothing needs to be pre-installed on the remote nodes, and this is, I think, another key aspect of this technology. Okay. Yeah.
I have two questions. The first one, can this be used on existing Incredible license?
Incredible license? Yes, it can.
What I mean, if you have the agents installed,
Yeah.
can you use this?
Yeah. Yeah. You have an XGE extension package. You can just contact me later on.
And my second question, do you have, in the first example, can you go back to the first example?
Yeah.
Yeah, this one. You showed how to run an executable file.
Yeah.
Now, do you have some kind of an API that software can use in order to decide which processes to run where?
Yeah. Okay, but this API is external to the application. This is one of the major benefits our technology provides. We don't want you to change your source code and architecture.
That I would like to change.
But the only thing you need to do in order to say if you want this process to run remotely or not is just... What?
It's the number of processes.
No problem, no problem. Just...
Yeah, but if I want full control, say, yeah, I want this process to run here, I want this process to run there.
We have, this is another interface which I didn't want to go into now, which is called the XML interface, which is much more complicated. There's a lot of directives and enable you to do a lot of things like groups. You can define groups of computers which you want to be a part of this specific job. You can describe priorities there. You can say how many of the CPU I want to use in the remote nodes, what will happen if a node will go down, which in XGE, if a node will go down, this particular job will simply restart in another node, and you will not notice it, because this is something, this is real commercial product which is working today, I think, with assets which are most important to companies like, for example, Adobe Flash Player is built using this technology, and it's crucial to have it as best as it can. I think that one of the important things, I cannot show you this demo now, but usually what you'll see here, if I could have showed you in my laptop, then you see here a lot of processes. This is, for example, a Maya tool, if you are familiar with the Maya rendering tool. So EA is using Maya in order to render all the animation and graphics for Sims. You're familiar with the game. So they do it using XGE, and they render their Sims animation with Maya, and they distribute this animation task, this rendering task, to multiple machines. And as I told you, we can handle thousands of nodes. And what you see here, if I could have shown you the demo, you could have seen in live. If someone will want, I will be able to show him to him later. You will be able to see on the fly how the processes are running on multiple cores. And if you go to the summary, or if you see the graphs, you will be able to see that the process you are using now is having several hundred of gigahertz of processes utilized, and you simply have a supercomputer of as many cores you put inside the environment. So process level virtualization is something which really gives you the benefit of both worlds, but it's not only this. We have a lot of other features which are grid features which come from the field, because a lot of our users are software engineers, and they are pretty spoiled customers, as you can imagine. And we have a lot of stuff like fault tolerance. We support VMware. You can scale out to the public cloud using this technology. So if you need several hundreds more machines, you can just go to the Amazon EC2. The only thing you need to install there is our agent, and this is it. You're ready to go. And a lot of other stuff which I don't want to take time from the current presentation. I just want to show you a real-life scenario, a real-life customer. One of our customers is an Israeli customer, which is Sarin. They are, I think, the leaders of diamond cutting software providers. What they do is they have a hardware, and they want to, they run a lot of simulations in order to understand which is the best and optimized way to cut a diamond in order to achieve the most profitable value you can from the diamond. And as you can imagine, they run thousands of simulations on how you can cut the diamond, because you have, it's like a chess game. You have endless ways in order to do it. So they were able to achieve a POC in no time, because as you saw, they just simply describe the processes they want to execute on their remote task with this XML interface. And they came from a 40 to 60 hours run on a large diamond to a 2 or 4 hours, depending on how many computers are involved in this operation. That gave them, that really changed the game. They currently are, I think, they just bypassed their competitors, because there is no other vendors of diamond cutting which can achieve this result. And it also changed the way they are actually working, because now they can do a completely different cycle of diamond cutting, because instead of taking for a large diamond, take them only 10 minutes. So it really changed the entire way they work with their customers. There are several factors which differentiate process level virtualization technology from other technologies, which are common grid technology and clusters. These are the main important ones. One of them is that you don't need to manage any resource. You don't need to virtualize the machine. If, for example, today I'm running Maya version 2 and tomorrow I have Maya version 3, I don't need to go to the entire nodes and just update the virtualized environment, because the next time I'll just execute my task, the nodes will receive the latest version on demand, on the fly. So there is no maintenance. You don't need to change your source code usually. If you are able to work in parallel, locally, you'll be able to work with XGE in no time. And we have actual customers which achieved it in several hours, running POC, and they achieved 30, 40 times faster executions. You don't need to maintain image banks, because the virtualization is on demand, on the fly. There is no dedicated hardware. And actually, what we have today with our customers, we have nodes installed on most of the computers available in the company, and we're talking about several thousands. And these computers are used to accelerate existing and running processes while a person is working on his computer. So for example, if we have a XGE agent installed on the secretary computer, usually what she does is just doing some Word or surfing the web with a dual quad machine or quad core machine or dual core machine. And she's using only 5%, 10% of the CPU, and the entire 90% is used by any software using XGE without her noticing it. She doesn't know that currently she's helping to accelerate other processes in the company. And if you'll take large companies, which usually are the customers we have, and the customers of CAD, CAM, and the extensive computational processes environment, they have all the computational process hardware they need in order to accelerate and to have the full acceleration they require from the software. The last thing I want to say is that XGE and process level virtualization as a technology is a cost-effective technology. So if you require a full-blown solution, real-time, microsecond, every microsecond counts, I don't know if XGE is the right technology for you. And if you want to invest several $1 million in order to achieve the best acceleration you can have, so if you have the money, go and invest it. But if we are talking about cost effectiveness, and by the way, an XGE agent has a 200 millisecond execution overlapping time, so it takes only 200 milliseconds in order to getting the helper agent up and running. So it's quite real time. But if you want a cost effective, then XGE will give you this cost effectiveness and the process level virtualization as a whole. And I think the most important thing is you can just try it in no time. You can just have a POC without having to learn and to understand which is the best grid or cluster environment which suits you best. You can just download. It's a software-based solution. You can just download it and try it without any investment, any real investment. And this is it. Yep. Any questions? Yes.
One thing you said that the program is used to run maybe 1,000 applications at the same time, or many programs at the same time, and you just spread them around.
Yeah.
On the other hand, the examples that you gave was just one task. I want to decide which diamond, how to cut the diamond, or another thing. And can you explain the?
Yeah. Okay. So let's say you have an application. So one thing is you can run as many applications as you want. I want to show you only an initiating machine, but you can have many initiating machines running on the same time in a single grid environment, in a single private cloud environment. But what I show you here is that you have one application which has a lot of sub-processes, okay? And then what we do is we take these sub-processes and distribute them to the remote nodes. Yeah.